good afternoon, or should I say good evening or good morning, depending where you are. Let us know in the chat where you're from. My name is Larissa Reis. I'm a PhD student at the Federal University of Goiás, here in Brazil. And it's my pleasure to welcome you to the fifth and final session of GBAE Day 2026. Our final lecture will be presented by Dr. Enid Pérez-Lara. Dr. Enid Pérez-Lara is a plant breeder with more than 25 years of experience across crops, industries, and continents. As industry engagement manager at Agronomix software, she collaborates with breeding programs in more than 40 countries, helping them harness digital tools such as Genotypes to support smarter data-based decisions. Featured in Seed World magazine and recognized as a speaker at major international events, she combines scientific expertise with strategic vision. She is also a strong advocate for women in plant breeding and deeply committed to mentoring and inspiring the next generation of plant scientists. Before she begins, I'd like to remind everyone that we'll have a question session at the end of the lecture. Please feel free to submit your questions and comments in the chat throughout the presentation. Dr. Enid, we are delighted to have you here with us today. I'll now hand the floor over to you.
Thank you so much, Larissa. Thank you, Pedro. Also, thank you to Camila, Renato, Bruna, and Rafael for preparing these sessions. I think it's a wonderful initiative for everybody across the globe to watch these sessions about GBAE. It's definitely a very important topic, especially for plant breeders like me. I'm sure today is a very hard act to follow because before me, very good presenters, brilliant people already presented about statistics side, about the real in the field breeding challenges, the models, deep rigorous things. So I'm very humbled to be here with you. I'm not trying to try to outscience that. That's not my talk today. So as you hear, I have more than 25 years in plant breeding, several countries and several crops. And my talk today is about all the spreadsheets I care to admit. So I want to share with you a little different story today. Is less questions and more story. Because behind every GBAE model is usually one very tired, very stubborn person who got tired and got fed up enough to fix something. And I happen to know one of those stories very well. So low stakes for me and no regression tables, I promise, just a story about a notebook, a frustrated breeder in 1990, and how that turned into a company, and not just a company, but a whole new industry that helps and supports today the breeding industry. So let's see if we can have some fun with it, with the story. So ask any breeder what actually keeps them up at night. And it's never or rarely the genetics. Actually, the genetics for plant breeders is the fun part. We love to search for new germplasm, search for new genes, identify new mutants, but always the environment gets us. So you have seen it probably. I have seen it firsthand. My first baseline in Spain, underperform in Italy. My third rank genotypes become a top performer when I confronted to the draw stress in Morocco. A variety with a very beautiful average of yield become completely collapse under organic conditions. And here's the trap. When you treat 60 environments as if they were a single environment, you don't simplify the problem. You destroy the very signal you are trying to select on. So let's be honest about what GBAE actually is. It is not a statistical inconvenience to smooth over a footnote in a report. It is a data management challenge at a big scale in the case of plant breeding. Because we have hundreds of environments, million of data points, we have or find missing values, our design become unbalanced, we have coding inconsistencies across, and decisions that need to be made in a very, very, very small window of weeks, not in the matter of months. So let me take you back to 1990. Dr. Dieter Mulitze was a professor at the University of Nebraska. He was not a software engineer. He was not a tech entrepreneur looking forward to become a millionaire. He was just a humble breeder and professor standing in a field. And he also frequently stared at data from 80 locations in field books. And he saw firsthand valuable information disappear due to formatting errors, inconsistent trait codes, and lost notebooks. So he didn't set up to build a new company. He set up to solve a problem. And that's a problem that every breeder before him knew existed, but nobody had fixed it. And that problem was G/E and G/E data management. Then our company, Agronomix Software, was born from it. So here's what made the difference. What breeders call a statistic problem, Dieter was able to identify it as a data architecture problem. And that reframe changed everything. So what a breeder sees is rank reversal, missing observations, or inconsistent trait names. But the software can see schema inconsistency, null propagation, ontology mismatches. And here is the genius part and how plant breeding software solved it. It created unified trait ontology engines. So the traits are all the same for everybody using the software. Smart imputations as well, immutable data provenance, and configurable partner connections. So it's the same problem across the three environments, but a completely different lens. And that's the entire story in a single slide. And now let's face something. There is not a single algorithm that can compensate for years of messy phenotypic data without traceability, storage in inconsistent formats. And most of us has commit one of these four data sins. So losing data. So we go to the field, we collect data on paper, we re-enter it manually in Excel, for example, column by column, row by row. We transcribe with errors because we don't remember the letter that we wrote under the sunshine, or we are entering somebody else's data. And here, a whole season can be lost. And this is not a technology failure, it's a workflow failure. Then tolerating inconsistency in the same trait. You have seen it probably. One person call it yield, a different person call it GY, another person call it grain yield T, another person yield 14%. 4 names for a single trait. So across 10 years and 5 breeders later, your data becomes unqueryable. Another scene is siloing by station. Your data lives in specific stations, like let's say per year, a spreadsheet part for the year, spreadsheet for the season, spreadsheet for different breeders. And then your G/E analysis, instead of being something simple, becomes a manual assembly project. By the time you have put together all your spreadsheets, the time period to make your decision is gone. Another thing is sharing without control. All plant breeders are very jealous of their material. So they can do 2 things. Either lock down everything and lose collaboration, or they share everything and then they expose their IP. And this is a false choice and can be solved with architecture, not just with a simple rule in the company. So the vision that guided the 35 years of Agronomix is very simple. Every data point needs to be captured, validated, and traceable from the time you take the data in the field to the time you make your decision. The codes for the traits need to be consistent across stations, seasons, and partners. So every breeder in the same program need to use the same codes. And these also need to be generated automatically to be more user-friendly. The GYE needs to be embedded in your daily workflow. So your script is stored in the software or in your database, and you don't need to repeat it or copy and paste every year. It lives there, and you can use it at any given time without hassle. And then the breeder can spend their time in what really matters for them, not on data playing around with Excel. So that has been the philosophy that our company put into the market. So far, this is the philosophy that has run in Agronomix since 1990 to the present time. We have a unified data hub with automatic format reconciliation, multi-site harmonization. So traits ontologies and environment descriptors are standardized across every location and every year. The GYE analytics are integrated, built into the software with no R scripting and no exporting to Excel or importing from Excel as well. The collaboration is controlled. That protects your material while still enabling partner data exchange. So you can take advantage of that exchange of collaboration, but you don't just let your IP visible to everybody. A full audit trail. So every decision is traceable. And when you do regulatory submissions, that's very straightforward. And most products today, our products and other ones in the market as well are cloud native. So performance doesn't degrade as your program scale to hundreds of trials or millions of data points or your team growing. And here's the payoff. When your data is clean, consistent, and connected, GYE stop being noise and start being signal. So look at this graph, for example. Same genotypes, 5 different environments. Genotypes A wins in 3 of the 5 environments, and genotype B wins in the other 2. Neither one is simply better. The environment is doing real work here. That rank reversal is made visible. Once you can see this clearly, 3 things become possible. You reveal rank reversal instead of averaging them away. You quantify true stability instead of mistaking a mediocre average for consistency. And you de-risk your pipeline decisions. You advance your material on evidence, retiring the poor performance early instead of relying on instinct. And this is the part that compounds. So here is what matters about GYE data. It is not a snapshot. GYE data is something that is across time, right? So every season, you don't start from 0. You rerun the same model, now with 1 more year of evidence, right? So this is not a model that uses AI or learn or fix itself. What actually happened is very simple. Every season, you rerun the same statistic with more data. So more data means less error, and that's the whole mechanism. But here's the part people misses. None of this work if your data lives in 40 Excels or in 40 laptops. A model can only build up in cleanly year after year if every season lands in the same place, same environment. Nobody needs to retype it. Nobody needs to reconcile it by hand every March in order to make your decisions. So what does more data actually buy you? In short, better estimates. With only 1 year or 2, you are almost guessing how much of what you see is genetics, how much is genotype per environment, and how much is noise. With more years, that guess becomes a real number. Variance estimates stabilize, predictions stop playing too safe, and correlations between environments converge on the truth. That's what this curve shows. And this is not real data, by the way. I don't have real data. And the last real data I had was not mine, so it was a private company. So this is just an example. In year 1, the model is right about 82% of the time. By year 5, is at 85%. Not because it got smarter on its own. Again, this is not AI, but because 5 years of clean, unified data let the same statistic finally do their job, the real job that it was designed to do. So as a plant breeder and as a member of Agronomix and somebody who really likes tech in agriculture and especially in plant breeding, these are some things that I would like to ask from you. Treat your multi-environment trial data as an strategic asset. Invest in platforms that unify, not just store your trial data. Demand G/E ready analytics built into your daily breeding workflow so you can reuse them many times consistently. Require interoperability between field capture, analytics, and decisions. And protect your IP without sacrificing collaboration, because they are not opposite. And last but not least, please honor Dr. Dieter Mulitze. His insight was very originally, and this data management problem was a problem that worth it to be solved. And then I thank you very much for your time. Thank you to the audience. This has been a very short talk, and here is my information. So if you want to reach out to ask me about any of my programs or any of my volunteering that I do across the world, I'm very happy to talk to you. And here is my social media, LinkedIn as well, where I'm very active and I share information about our challenges in plant breeding and about women's in breeding and helping young people to find the right path. So thank you very much for everything. I'm open to questions.
Thank you very much, Dr. Enid. What a story and what a insightful presentation. We'll now move on to our Q&A session. I have a question here from Camila. Camila asks, from an industry perspective, what are the most critical data quality issues in multi-environment trials, and how can they affect G/E modeling and genotype recommendation?
Okay. So I'm not a statistician myself. I'm just a modest plant breeder. But one thing that I have seen a lot is, as I mentioned before, is seeing data, missing data, a lot of missing data. And something that worries me is like most of the time it's not data that got missed because a plant died or we lost some genotypes or some blocks in our experiment. It's pretty much the quality of the data collection. So it's very important to have the right tools when you are collecting your data. Check that everything has entered properly, and then you stop missing data for those reasons. And then, yeah, the quality would be better at input instead of being able to clear or control it later on in the process.
Okay, thank you. The other question is, how should breeding programs organize phenotypic, genotyping, environment, and management data so that multi-environment data sets remain useful for predictive modeling over several years?
Oh, that's very important. That's very important. Something I missed to say in my presentation is like without consistency in your data collection across several years, um, breeding selection and genomic selection, etc., become more difficult. So nowadays we have all the tools in the marketplace to create like very powerful, complete databases with your data. Um, Software like Genotypes, for example, can host your phenotypic data and your genotypic data as well, and can host also the script for the models and everything, so you can work consistently across years. But once again, to have the data storage in the same environment with trait ontology correctly done save you a lot of time. So using platforms like Genomics, like the one that we have created, save you time and help you to do a better job at using new technologies. So that's for sure. If you don't have your data, it doesn't matter if you have 20 years of data, if it's messy, if it's inconsistent, so it will be difficult to assemble one project of breeding selection, for example. So yeah, it's important to use the tools that are available to the breeder. And I don't know the audience today where they are from, but probably many of them have heard about different products in the marketplace for plant breeders. I would strongly recommend them to use them. It's really important if you want to jump to the new technologies like enviromics or genomic selection, prediction of hybrids or prediction of parental types. Host your data in a good place, in a single location where you can execute all these models.
Okay, thank you again. So Salvador, our previously speaker, said, thanks for the nice overview. Is there any analytics added, particularly to fit GBI models in the software?
Yes, yes, we have several GYE models stored in Genotypes. Of course, they are they were designed for plant breeders. So we have like we have oh, I have a blank time in my brain right now, but we have several of them, like stability test for sure, Shukla stability test, and we have other many models built into the software for GYE. Yeah.
Okay. The other question.
Cultivar superiority as well. Yeah, we have several models there.
A very complete software then. Yeah. So then, in large breeding pipelines, how can historical, it remains from the other question that I asked you, how can historical trial data be standardized without introducing bias caused by changing experimental design, location, checks, trial, or scoring methods?
Yeah, so importing historical data can be more challenging or not. Definitely, for example, Genomics has tools to standardize that at import. When the format that you are trying to import is not very consistent, we always can create scripts to import it. But for example, if you are trying to import data from Excel, for example, it can be standardized at import, very straightforward. If you are coming from other platforms, it's a little bit harder, it's a little bit more complicated, but always can be solved by scripting. But yeah, we have clients that have imported 30 or 50 years of data from Excel without problems.
Okay. I have a personal question. What's the biggest challenge in designing software for plant breeders? Because I was helping my superior design a software. It was like very DIY software about trial design. And for you, in your experience, what is the biggest challenge?
Yeah, so I'm very lucky because I just optimize something that already existed. And I surprised myself with how many tools this software has. So I think Dieter was really a genius. He was a statistician himself, so he put a lot of experimental designs into the software. But I think the biggest challenge is understand all the different crops we work with. So not every single crop works like the other one. People bring and use different experimental designs. Time to time, somebody appears with a completely new experimental design that we didn't take into account. So we gladly build them for them. We build those algorithms for the new clients, but it's fascinating see it work across so many crops and plants and see what different breeders use. Sometimes you get surprised the methods they use. So when it's a global and very agnostic software as ours, so yeah, it's fascinating to work with different type of breeders at different levels as well. Some people do just crosses and selection. Other people are doing sales, for example, and they do more commercial trials. So it's not the same knowledge across all of the users that we work with. So I think that's the biggest challenge. Like, and again, if you are starting a software de novo, it should be super complicated because then you know what you know, right? But the Dieter's perspective was unique, and also he developed this product over 30 years. So it's 30 years of interaction with different breeders, and he was learning from them, right? So he always said that this was a product built by breeders for the breeders, because it was just all what is contained in genomics has been 30 plus years of interactions with breeders as well. So it's not a single way. We learn as well from our clients.
For sure. Thank you. João Zanon asks, how open and extensible is Agronomix? For example, can users integrate custom code written on R or Python and add their own analytical workflow?
Yeah. So we have our own statisticians who build codes or R scripts for the analysis of our users. But then also our users have the possibility to integrate their own R scripts in the software. They just need to follow some instructions that we will send them. And then, yeah, once the script is in Genotypes, they can keep using it consistently all the time.
Okay, thank you so much, Dr. Enid. We truly appreciate your taking your time to share your knowledge and experience with us. We hope to have the opportunity to welcome you back in the future, in person maybe.
Thank you. Thank you so much. I hope.
Yeah, I hope too. Bye-bye.
Thank you so much. Have a good day. Bye-bye.
Thank you. Bye-bye. As we come to the end of GE Day 2026, on behalf of everyone at LAMP, I would like to sincerely thank everyone who made this event possible. First, I would like to express our deepest gratitude to all of our speakers for sharing their knowledge, experience, and insights throughout today's program. Our sincere thanks also go to our partner study groups, Eugene from UFG, Jane from UFLA, Jiven from Eeuwijk and USP, Jane Melhor from UFV. We also gratefully acknowledge the support of our graduate program in genetics and plant breeding at UFG and our partner startup, The Crop. A special thanks goes to our tech team, Pedro, Michelle, and Renato, for ensuring that everything runs smoothly behind the scenes. We are also great for our marketing team, Bruce, Camila, Cadu, Roger, Lucas, Marcos, and Gustavo, for helping us promote the event and engage our audience. A special thank to Eduardo, my scientific committee partner, for helping shaping the theme of this event. We also like to thank Bruno for all his support with human resources. Our sincere appreciation goes to our coordinators, Bruna and Larissa, not me, the other Larissa. Thank you, girls, for the leadership throughout the organization of GBI Day. Finally, I would like to express our gratitude to our professors, Professor Marcela Mendes for the continual support, and Professor Rafael Tassinari Resende, whose vision made GBI Day come to life. Last, but certainly not least, thank you all who joined us today from different countries and institutions. We hope you enjoyed the lectures and learned something new. And we hope to see you again in future editions of GBI Day. Have a wonderful afternoon, night, or day, everyone. Bye bye.